Assalamualaikum warahmatullahi wabarakatuh and good evening. So today we would like to present our lab report for makmal kejuruteraan kuasa 3. So our lab project entitled Protective Relay. So my lab member is me, Naim Rizuan bin Zaid, Scovien Olle Lawrence and Muhammad Nur Razin bin Hayadin. So, okay, next. First of all, what we will you do in this activity? So, as you can see, this is the equipment used in the lab. So, we have to connect the circuit from the equipment for each other. So, next, resetting ratio of under voltage over voltage time relay. Next, adjustment of under voltage over voltage time relay, and the last one is inverse time over current relay. Okay, next, what is DTR? DTR means definite time relay, which is a relay that operates after a definite period time once the current exceeds the pickup value. Hence, the relay has current setting range as well time setting range. It is used to coordinate over definite time or instantaneous protection. What is ITR? ITR means inverse time relay. It is overcurrent relay which operates only when the magnitude of the operating current is inversely proportional to the magnitude if the current. Next, use when to coordinate is not required. I would pass my present to the next member.
Okay, hello everyone. Okay, my name is Scovien Lawrence. Today I will present about the connection and result. I will start with the component of ITAR connection system. There are 4 components, which is 3-phase power supply, under voltage, over voltage time relay, voltmeter, and acoustic continuity tester, which is buzzer. So this is the component, which is this is the relay, this is the buzzer, this is the voltmeter, and this is the 3-phase power supply. So the connection is actually very simple. The L1, which is the red phase, will connect to the voltmeter, and the yellow one, which is the L2, also will connect with the voltmeter, and the red and yellow phase will connected to the relay. In this relay, actually, which has over voltage and under voltage relay, the L3, which is the blue phase, will connect directly to the relay, and then we connect to the buzzer. Okay, so we continue to the under voltage operation next. So I will explain briefly about the under voltage operation. First of all, we need to reset the system. To reset the system, we must push stop the button first. Then we can hold start the button. When we push start the button, we increase voltage until 380 line to line. Then we slowly decrease the voltage until the buzzer is triggered or alarming. Then we can take the voltage result, which is voltage operating VO, which is 366. Then we slowly increase the voltage until the buzzer stop alarming, and take the result, which is VR V relay 377. So next, for our voltage operation, first of all, we must push stop the button first to reset the system. Then we push start the button and increase the voltage until 380 line to line. Then slowly increase the voltage until the buzzer is alarming. Then we take the result, which is VO, voltage operating. The answer is 408. Then slowly decrease the voltage until the buzzer stop alarming. Then we can take the result, which is VR, voltage relay 402. So actually the operation is quite similar, but we may take the result is different. So to calculate the under voltage and over voltage operation, we use a same formula, which is KR equal to VR over VO. So VR over VO, we get the answer, which is 1.03. And same of over voltage operation VR over VO, we get 0.99. So next, we continue the slide with the ITR connection. In the ITR connection, we have several components more than the TR connection. So for the ITR connection, we have three-phase power supply, three-phase transformer, resistive load, power circuit breaker, inverse time over current relay, emitter, acoustic continuity tester, buzzer, and electronic stop clock. Okay, next. So this is the connection for ITR. This connection is a bit complicated. It's very difficult to see properly. So we will go through to the result next. Okay, from the lab sheet, we only got R load, I, and TM. For the load, the result we calculate in ohm, I, ampere, and TM in seconds. So in this table, we can briefly see that when the R load is in high position, which is increase, and the I also will increase, and timing will decrease. The trip time will increase, same with the TC timing time. When the R load decrease, the I will also decrease, but trip time for TM and TC will increase. So as you can see, 7, 1.7 for the I, the TM trip time for TM is 8, and TC 7.57. But when the R load is 4, 4, the I is 0.7, and the time for the trip time for TM and TC is increased to 48 and 83.33 respectively. So how we calculate the TC? So this is the formula we use. Next, the I for this one for R load 7, the I, which is 1.7, we put in the formula, and 0.5 is constant, so we get 7.57 TC. Then next one is the I is 1.4, and we get the result is 11.69 seconds. For the R5, we use 1.1, and we get 20.83. For R load 4, we use 0.7i, we get the result, which is 83.33. So that's all for my presentation. I hope it is easier to understand my explanation. Thank you.
Okay, my name is Muhammad Nur Razin. Today I will present for the conclusion. Finally, student grasp the significance of protective relays and the distinction between under voltage and over voltage operation. Student calculated the resetting ratio KR as well as the trip length TC for both under and over voltage condition in this experiment. Additionally, by connecting the relay and the inverse time over current relay, student may witness how the behavior changed during the recorded journey time. Students should use caution when completing the exercise to ensure that they utilize the right calculation and achieve an accurate result. Finally, when the resistance value falls, the current reduces and the travel duration increases. And that's all from our group. Thank you.